The scientific revolution, spanning roughly from the 16th to the 18th centuries, was a transformative period that profoundly reshaped science, philosophy, and the way humanity understood the natural world. It marked a break from traditional, often religious explanations of the cosmos and embraced empirical observation, experimentation, and rational inquiry. This movement laid the groundwork for the modern scientific method and opened the door to a series of remarkable advancements by figures like Antoine Lavoisier, Michael Faraday, and Charles Darwin, each of whom revolutionized their respective fields and left an indelible mark on the trajectory of human knowledge. The foundations of the scientific revolution. Before the scientific revolution, explanations of natural phenomena were often rooted in religious doctrines or the works of ancient philosophers such as Aristotle and Ptolemy. These traditional frameworks held sway for centuries, emphasizing geocentrism, the immutability of species, and the primacy of divine intervention in the natural order. However, by the 16th century, a series of intellectual, cultural, and technological developments began to challenge these long-standing beliefs. The Renaissance, 14th, 17th centuries played a critical role in the emergence of the scientific revolution. Renaissance humanism, with its focus on rediscovering classical texts and emphasizing the potential of human reason, encouraged a spirit of inquiry and skepticism. The invention of the printing press in the mid-15th century facilitated the rapid dissemination of ideas, allowing scientific discoveries to spread across Europe. Finally, the Age of Exploration provided practical incentives for better navigation and understanding of the natural world, fueling interest in astronomy, physics, and biology. The works of early figures like Nicolaus Copernicus, Galileo Galilei, and Johannes Kepler laid the foundations of the scientific revolution. Copernicus's heliocentric model of the universe challenged the geocentric view, while Galileo's use of the telescope provided empirical evidence to support Copernicus's claims. Kepler's laws of planetary motion, based on meticulous observations, further demonstrated that the heavens operated according to mathematical principles. Antoine Lavoisier, the father of modern chemistry. One of the most pivotal figures in the scientific revolution was Antoine Lavoisier, 1743 to 1794, a French chemist whose work fundamentally transformed the field of chemistry. Lavoisier is often regarded as the father of modern chemistry because he introduced rigorous quantitative methods and established a systematic approach to chemical investigation. Lavoisier's most significant contribution was the discovery of the role of oxygen in combustion. Prior to his work, the phlogiston theory dominated chemistry, proposing that a mysterious substance called phlogiston was released during combustion. Lavoisier disproved this theory through careful experimentation, demonstrating that combustion involved the combination of a substance with oxygen from the air. This insight not only clarified the nature of combustion, but also led to the formulation of the law of conservation of mass, which states that matter is neither created nor destroyed in a chemical reaction. In addition to his groundbreaking experiments, Lavoisier introduced a systematic nomenclature for chemical substances, standardizing the names of compounds and elements. He also helped define elements as substances that could not be broken down further by chemical means, a principle that remains central to modern chemistry. Tragically, Lavoisier's life was cut short during the French Revolution, but his contributions laid the foundation for future advancements in chemistry and established the discipline as a rigorous science. Michael Faraday, advancing the field of electromagnetism. Michael Faraday, 1791 to 1867, an English physicist and chemist, is another towering figure whose discoveries reshaped the scientific landscape. Faraday's work in electromagnetism and electrochemistry not only expanded our understanding of the physical world, but also laid the groundwork for numerous technological innovations. One of Faraday's most significant achievements was the discovery of electromagnetic induction, the process by which a changing magnetic field generates an electric current in a conductor. This principle, which he demonstrated in 1831, forms the basis of modern electric generators and transformers, making Faraday a key figure in the development of electrical power systems. His experiments showed that electricity and magnetism were intimately connected, it paving the way for James Clerk Maxwell's later unification of these forces into a single electromagnetic theory. Faraday also introduced the concept of field lines to describe the influence of magnetic forces, providing a visual framework that remains widely used in physics. In addition, his work in electrochemistry led to the discovery of several fundamental laws, including Faraday's laws of electrolysis, which describe the quantitative relationships between electric current and chemical reactions. Despite having little formal education, Faraday's brilliance and experimental skill earned him widespread recognition. His work not only transformed physics, but also spurred the development of practical technologies, from electric motors to telecommunications. Faraday's legacy is a testament to the power of curiosity, perseverance, and the scientific method. Charles Darwin, revolutionizing biology. The contributions of Charles Darwin, 1809 to 1882, to the field of biology marked a paradigm shift in the understanding of life and its diversity. His theory of evolution by natural selection, articulated in On the Origin of Species, 1859, provided a unifying explanation for the development and adaptation of species over time. Before Darwin, most naturalists adhered to the belief that species were fixed and unchanging, a view consistent with religious doctrines. However, Darwin's observations during his voyage aboard HMS Beagle, particularly his studies of finches in the Galapagos Islands, led him to question this perspective. He noticed that closely related species exhibited variations that seemed to be adapted to their specific environments, suggesting that species could change over time. Darwin's theory of natural selection posited that individuals with traits better suited to their environment were more likely to survive and reproduce, passing those advantageous traits to the next generation. Over long periods, this process could lead to the emergence of new species. Darwin's work provided a naturalistic explanation for the diversity of life and challenged traditional views about the origins of species. The impact of Darwin's ideas extended beyond biology. His theory influenced fields such as anthropology, psychology, and sociology, sparking debates about humanity's place in the natural world. While Darwin faced significant criticism from religious and scientific communities, his work ultimately became the cornerstone of modern evolutionary biology. The philosophical implications of the scientific revolution. The advancements of Lavoisier, Faraday, and Darwin are emblematic of the broader intellectual shifts brought about by the scientific revolution. As scientists uncovered the underlying principles governing the natural world, traditional explanations rooted in theology and superstition were increasingly called into question. This shift had profound philosophical implications, giving rise to new ways of thinking about knowledge, existence, and humanity's relationship to the universe. One key development was the emergence of empiricism as a dominant epistemological framework. Philosophers such as Francis Bacon and John Locke championed the idea that knowledge should be based on observation and experience rather than abstract reasoning or dogma. This emphasis on empirical evidence became a hallmark of the scientific method and continues to underpin scientific inquiry today. The scientific revolution also contributed to the Enlightenment, a cultural and intellectual movement that emphasized reason, individualism, and progress. Thinkers like Voltaire, Immanuel Kant, and David Hume drew inspiration from scientific advancements, arguing that rational inquiry could be applied to social, political, and ethical issues. This optimism about human potential and the power of reason helped shape modern democratic and liberal values. The scientific revolution and the contributions of figures like Antoine Lavoisier, Michael Faraday, and Charles Darwin represent a watershed moment in the history of science and philosophy. These pioneers not only advanced their respective fields, but also exemplified the transformative power of the scientific method. Their discoveries reshaped humanity's understanding of the natural world, challenged long-held beliefs, and laid the foundations for countless technological and intellectual advancements. Today, the legacy of the scientific revolution continues to inspire scientists and thinkers, reminding us of the enduring value of curiosity, skepticism, and the pursuit of knowledge.